For friends who are attempting to participate in car camping activities, building a power system is the most challenging part of car camping. This requires mastering multiple related concepts and calculations, as well as understanding the specifications of various equipment. The goal of this video is to provide practical and easy-to-understand information so that everyone can build a simple, safe, and efficient car camping power system. A basic car camping power system is not complex. It consists of three parts: charging methods, energy storage devices, and electrical appliances. First, let's understand the energy storage devices. Unlike the large power grid, which only has options like dams for energy storage, there are many choices for small-scale direct current energy storage devices, ranging from small to large capacities and various materials. Below, we will introduce battery storage devices for storing DC electricity based on their types, capacities, and voltages. The function of a battery is to store energy obtained through the charging method and supply it to operating devices. Different battery types have differences in terms of lifespan, safety, and price. Common battery types for car camping include 1. Lead-acid and AGM batteries, currently, one of the most widely used types of batteries. They have the advantage of being low-cost, but they are heavy and have a short lifespan. Additionally, it is not recommended to discharge lead-acid batteries below 50% of their capacity as it significantly reduces their lifespan. 2. Lithium-ion batteries, currently one of the advanced battery technologies. They have the advantages of high energy density and lightweight. However, they are expensive and contain flammable materials, so safety precautions must be taken when using them. 3. Lithium iron phosphate batteries, a high-performance lithium-ion battery with high energy density, low internal resistance, and a long lifespan. Compared to lithium-ion batteries, it has good thermal stability and chemical stability, making it safer. Each battery type has its own advantages. However, considering the excellent performance of lithium iron phosphate batteries and the impact of recent advancements in battery technology in decreasing prices, many car campers have chosen to use lithium iron phosphate batteries as their car camping battery packs. Many batteries in the market sometimes have suspicions of misleading or deceiving consumers in terms of energy capacity labeling. The following situations often occur. 1. Confusion, intentionally using milliampere-hour to display large numbers. We must understand the conversion of battery energy capacity to avoid being misled. For example, a lithium-ion battery labeled as 10,000 mAh is equivalent to 10 ampere-hours. Then, multiplied by the battery's voltage of 3.7 volts and multiplied by 0.001, we get the common energy unit, 0.037 kilowatt-hours. We can see that the actual usable energy is not much. 2. Incorrect labeling, adding the ampere-hour or milliampere-hour values of cells connected in series. For example, if four 3.2 volt, 100 ampere-hour batteries are connected in series, the correct labeling should be 12 volts and 100 ampere-hour. However, it might be mistakenly labeled as 12 volts and 400 ampere-hour. Both ampere-hour and milliampere-hour are units for expressing charge capacity and must be multiplied by voltage to represent the battery's available energy capacity. For example, for batteries labeled with the same 100 ampere-hour, a 12.8 volt battery would have an energy capacity of 1280 watt-hours, while a 25.6 volt battery would have an energy capacity of 2560 watt-hours, which is twice as much. Watt-hour directly represents energy and provides a more intuitive understanding of the battery's available energy. Different battery types have different nominal voltages. For example, lithium-ion batteries have a nominal voltage of 3.7 volts, while lithium iron phosphate batteries have a nominal voltage of 3.2 volts. Common voltage specifications for car camping battery packs are 12 volts and 24 volts DC. To build a battery pack, multiple batteries need to be connected in series. For example, 8 lithium iron phosphate batteries or 7 lithium-ion batteries can be connected in series to create a 24-volt system. After assembling multiple batteries into a battery pack, a battery protection board must be added. The battery protection board safeguards the battery during charging and discharging and balances the voltage of each individual battery. I recommend using an active balancing battery protection board, which can efficiently achieve capacity balancing among batteries, significantly extending battery lifespan and performance. Additionally, while many people assume that the voltage specification for car camping batteries should be 12 volts, this is mainly due to the possibility of utilizing the vehicle's alternator to charge the battery pack through the installation of an isolator. However, this method is not recommended, and the reasons will be explained in detail in the charging section later. Some people consider using a 12-volt battery pack because their vehicle is equipped with a 12-volt starting battery. This allows them to connect the battery pack to the vehicle's battery for emergency situations when the vehicle's battery is depleted. However, situations where the vehicle battery is completely dead are not very common, and it is now easy to find compact emergency power sources on the market, so I do not recommend this approach. Some people believe that 12-volt appliances are more common in vehicles, so they choose a 12-volt battery pack. We will create another video to explain whether 12-volt or 24-volt appliances are more practical. Another important fact is that when using devices with the same power rating, a 24-volt system only requires half the current compared to a 12-volt system. This means that a 24-volt system does not require larger wire gauge, providing a significant advantage in terms of wiring layout. I strongly recommend using a 24-volt battery pack to establish the power system, as it can achieve higher output power with lower setup costs. Once the energy storage device in the system is determined, the next step is to carefully select the electrical appliances for car camping. To avoid excessive battery consumption or overloading the electrical system, it is important to consider the power requirements that match the capacity of the energy storage device when choosing electrical appliances for car camping. Therefore, the first step is to select suitable appliances and calculate their power consumption. Initially, some people may consider using household appliances directly. However, household appliances are designed to operate on 110 volts or 220 volts AC power. In order to use them with a battery pack, an inverter must be installed between the battery pack and the AC appliances to convert the DC power output from the battery pack into 110 volts or 220 volts AC power. However, this conversion process incurs an energy loss of about 10 to 20%. When selecting an inverter, it is crucial to ensure that its power rating is sufficient for the AC appliances to avoid overloading the inverter. It is also important to note that inverters require proper ventilation space. Installing an inverter takes up limited space inside the vehicle, and the noise generated by the cooling fan can disrupt daily activities. Another major issue is the high starting current required by inductive load-type AC appliances such as air conditioners, microwaves, and induction cooktops. These appliances often need several times the operating power for startup, which means the inverter's wattage should be significantly higher than the operating power. The high starting current can also cause a significant voltage drop in the battery, leading to a rapid decrease in voltage even when the battery still has about 1/3 of its capacity remaining. As a result, it may not be possible to start the appliances through the inverter. Moreover, many AC appliances are not compatible with the modified sine wave produced by inverters, rendering them unable to operate properly. These reasons are why we strongly discourage the use of inverters. On the other hand, many commonly used household appliances such as refrigerators, air conditioners, washing machines, electric kettles, rice cookers, electric stoves, microwaves, and induction cooktops have DC-powered versions available for car camping. These DC appliances are specifically designed for car camping, with power ratings that match the output specifications of battery packs, and they are also more compact and easier to store. Therefore, I recommend purchasing DC-powered appliances specifically designed for car camping instead of using household appliances directly on the vehicle and adding an additional inverter. To estimate the power consumption, the first step is to understand the energy usage of each device. The power rating, measured in watts, is usually indicated on the device or in the user manual. Multiply the power rating by the duration of use to calculate the energy consumption of each device. For example, if an air purifier has a power rating of 60 watts and is used for 24 hours a day, the daily power consumption would be 60 watts * 24 hours equals 1440 watt-hours. Create a list of all the devices used for car camping and multiply their power consumption by the daily usage time to obtain the daily energy consumption for each device. Sum up the daily energy consumption of all devices and estimate the number of days for car camping to determine the total energy consumption data. Based on this data, you can choose an appropriately sized battery pack. Once you have the energy storage device and the electrical appliances, the next step is to understand how to replenish the power supply. There are three main ways to charge the battery system in a van conversion for camping: using household power, connecting the battery to the vehicle's electrical system, and utilizing solar power. I would recommend using both household power and solar power to charge the battery system, while avoiding the option of connecting to the vehicle's electrical system. Connecting the additional van conversion battery to the vehicle's electrical system is not recommended because the vehicle's parts and starter battery are designed to be powered by the internal generator. Even with an isolator installed, connecting an additional battery may overload the generator, leading to premature aging or failure and unexpected inability to start the vehicle. There are also important details to consider with the other two charging methods. To charge the battery with a charger equipped with a transformer, you can simply connect it to a household or campground outlet. However, relying solely on this method means you cannot venture far from the city grid and may face limitations in terms of route and timing. It's important to note that battery chargers are not interchangeable between different types of batteries. For example, lithium iron phosphate batteries and lithium batteries have different voltages and require their respective dedicated chargers. The charging connection sequence is also crucial. It is recommended to first activate the main power source of the battery system, then connect the battery charger to the battery, and finally plug in the charger to start the charging process. This helps avoid the risk of damaging the protection board components due to sudden power surges. Many battery specifications highlight the feature of fast charging. However, many campsites provide limited power wattage, and using fast charging may cause the circuit breaker to trip. Based on research on battery charging and discharging rates and battery lifespan, it is better to choose a battery charger with lower charging wattage, which places less demand on the charging environment and is beneficial for maximizing battery cycle life. By compensating for the lower charging power with longer charging times, you can optimize the battery lifespan. Among the free sources of electricity generation, wind power, hydropower, and solar power are available, with solar power being the most efficient. A solar energy storage system mainly consists of solar panels, a PWM/MPPT solar charge controller, and the battery system. The efficiency of solar panels varies depending on their structure and materials. Common solar panels for van conversions include the most efficient monocrystalline silicon panels, polycrystalline silicon panels, and flexible thin film panels. Regardless of the type of solar panel used, it's important to calculate the power requirement. For example, if the daily power consumption is 1,200 watt-hours and the average daily sunlight exposure is 5 hours, you would need a 240 watt solar panel to charge the battery system. If using multiple solar panels, they can be connected in series or parallel. Finally, the key component is the solar charge controller, which serves as the control center of the solar charging system and comes in two types, PWM and MPPT. Compared to PWM controllers, MPPT controllers offer excellent efficiency. They continuously track and adjust the voltage of the solar panel to generate maximum power and regulate the voltage and current generated by the solar panel to match the charging specifications of the battery system. MPPT controllers are critical for maximizing the efficiency of the solar charging system. These are the various charging methods for a van conversion explained. In summary, a basic van conversion electrical system includes various components such as charging methods, energy storage devices, and electrical appliances, forming the foundation of the system. Depending on each person's camping style and duration, the specific items and costs within the system may vary. I have chosen a 24-volt DC electrical system and utilize various DC appliances, which allows me to simultaneously run multiple appliances efficiently. I can also supplement the power with solar energy, ensuring an abundant power supply. By avoiding the use of high-power AC appliances and instead opting for equivalent DC appliances, I eliminate the need for an inverter in the power system, thereby avoiding additional conversion losses. This increases the overall efficiency of power utilization, creating a convenient and efficient electrical system for van camping. This system provides many conveniences and comforts for my van camping trips and is suitable for players like me who do not have an RV or engage in extensive modifications. However, if you have a larger RV with more available space, the demand for electrical appliances may increase, requiring a more extensive power supply. In such cases, the entire van conversion electrical system would need to be considered differently. Thank you for watching.